housing types, ages of properties, occupancy, various variables there that we looked at. We then went through a recruitment and booking period, getting out to customers, identifying the customers, getting them to come in, getting them booked in. And the site visit then really was about a general audit. It was a free home water check, within which we would look for leakage within the WCs. Now the types of data that we collected on that site visit ranged from property data, some of which we had already, data for other water using appliances, showers, taps, etc. and also all WC fitting related conditions. So we were looking at whether you were looking at the flush type, we were looking at the volumes, the actuation, the different mechanisms for the inlet valves, etc. So we were looking at all the different range of WC fitting conditions, and we were noting those. So in terms of outcomes from the phase 1 part of the investigation, we had, it's fair to say, quite a low initial uptake. And we decided as a team, as a group, that we would extend the survey, the work from United Utilities into Affinity Water. And we actually sent out the same letter to 2,000 more customers in the Affinity Water region. Importantly, we also had a high dropout rate. So customers that wanted a visit, but then we couldn't get hold of them, they gave us wrong numbers, or various number of reasons gave us this high dropout rate. And that was about 40%. So from those that said they wanted a visit, 40% actually dropped out. In total, we were able to investigate 145 WCs as part of phase 1, and of which we identified 6 were actually leaking, and we were able to instigate repairs on those, and I'll come on to that in a moment. Now phase 1 was about testing the hypothesis that 10% of all WCs leak. And from the data here for Warrington and Luton and the combined data, you see we have a range of averages for our sample. So we looked at the 95% confidence intervals for that data, and really that meant that we could say with some certainty that the mean value actually lies, the mean value for the population, I should say, actually lies within a given range. So for the Warrington sample, we can say that we're 95% confident that the leak rate within the Warrington sample, or the Warrington population I should say, is between 2.5% or 2.4% and 12.5%. In other words, we are 95% confident that between 2.4 and 12.5% of all WCs in Warrington actually leak. The same for the combined sample, where the actual confidence intervals are slightly smaller, 1.7 to 8.9%. Now the Warrington sample, as you can see, the original 10% hypothesis sits well within that, so that works quite nicely. However, for the combined sample, it's slightly more. Now the analysis also suggests that there's perhaps some regional variation, which is what we wanted to actually preclude right from the start in the way we designed this. But from the overlap of the confidence intervals, we can actually conclude that that might be minimal. The impact might not be as significant. Now the figures here are broadly in line with other water company initiatives that had happened over the last few years, which generally suggested that between 5 and 7% of WCs are actually leaking. So phase 2 was about looking and drilling down into the leaking WCs themselves, looking for the causes of those leakages. And this was run in parallel to phase 1 because of the recruitment challenges that we had in phase 1. Now for phase 2, we were looking to
have joined the conference.
Identify 300 leaking toilets, known leaking toilets, and I've listed there some of the initiatives that we piggybacked on, if you like, to identify those. And we expected those to be able to fulfil that number. As it happens,
have joined the conference.
As it happens, that didn't quite work out, so we had to go to Plan B, and that was to direct mail leak strips out to 9,000 customers across 3 water company regions, so 3,000 in each water company region. The site visits for phase 2 were then really about identifying the leak type and the cause, measure the leakage rate, how much water is being wasted, and to repair that leak. So, from the 2 phases of the physical investigation, we analysed 468 WCs, of which we found 138 were leaking, of which we were able to repair 126. Now, I've mentioned that we had some recruitment challenges, and I think that's reflected in the numbers. In fact, there was a bit of a feeling at one point that we could go on for another 6 months and still not get to the numbers that we needed to. We also found that identifying the leaking WCs was quite challenging. There was quite a dropout rate in phase 2 as well, in terms of the plumber would turn up and the customer would have already fixed the leak. Because it had been identified through another initiative, they knew they had a leak, so in some instances they'd gone away and fixed it. We found that there was some potential for incorrect application of the leak strips, so again, we were being notified of a leak, we were going out and there wasn't a leak. So all told, our sample size was a lot less than we anticipated, but as I mentioned, we decided to go ahead with the 138 leaks that we actually had and do the analysis on that. And we found there's a large range in leakage rates, and you'll see phase 1, a few leaks between 1 and 120 litres per day. However, phase 2, very small leaks right to some very, very large leaks, which we actually cross-checked and made sure that they were correct. 3,600 litres per day, which is quite considerable. In a small number of properties, we found they had more than 1 leaking toilet. However, for the analysis, we took every WC as being independent. So there was no, so for the analysis, we didn't suggest that there was a reason for more than 1 to be leaking in the same property. And access issues at some properties were a problem for us in terms of getting leaks repaired. Concealed cisterns hidden behind tiled walls meant that actually we couldn't access them, or access was very limited. So hence, from the number of total leaks, there were about 12, I think, that we didn't manage to fix. So looking at the leakage rates, and you'll see that we've got a range of leakage rates, which I mentioned, but it's clear that the data's actually positively skewed, and the data is influenced by those few large leaks. Now, that's actually pushes the average values up for the leakage rates. Now, just to give you an indication, 80% of all leaks were less than 300 litres a day. Some 36% were less than 25 litres a day. Only 12% were above 500 litres. And I think there may be some reflection in terms of the way the data was collected, the types of customer that we were targeting, and the initiatives that we were targeting them through. But that all said, our mean and our median values, and this type of skewed data, sometimes it's better to reflect the average on the median value rather than the mean, are very much lower than other industry studies. So for the mean here, it's 215 litres a day. Our median value is 72 litres a day. Now that suggests that the contribution to PCC may not be as high as 9% as initially anticipated. Now if we look at the a 4.1% leakage rate, which we established in phase 1, and the confidence intervals around those for the median value, that would give us 1.7 to 3% contribution to PCC, so much less than the 9%. If we took the mean value, it's between 4 and 9%. So again, on the top end of it, it falls within what the previous study found. Overall wastage, we estimate to be, based on the mean, 397 megalitres a day, and overall wastage based on the median is down to 133 megalitres a day. Okay, so we wanted to drill down into the causes a bit more of the leaks and really start to explore the relationship between certain WC characteristics and whether there is a relationship. Now the table at the bottom, and apologies if it's difficult to see, it's really there to illustrate a purpose essentially, but it compares the characteristics of WCs and properties for those that are leaking and not leaking. Now initially we looked for any correlation in the data between the variables, basically to see if how strongly related two variables might be to each other. Now, the nature of the data that was collected was very much binary. It's either X or it's Y. So this limited this type of analysis, and it showed actually all the correlations were fairly weak, which was understandable. So to test it further, we used chi-squared, and really this was almost to demonstrate excuse me, whether the differences that we're seeing at the bottom are actually statistically significant. Now, those in yellow at the bottom, through the chi-squared analysis, we found to be statistically significant. However, some characteristics, as you might imagine, come as a package. WC has a push button. It may therefore have a flush valve, and it may be 6 litres or it may be dual flush. So some things come as a package. So we've got to cut beyond that, if you like. However, the relationship between flush valves and leakage was highlighted to be statistically significant. And the other point from the data really was a quite interesting one, that WCs in houses built between 1970 and 2000 were actually less likely to be leaking than WCs in other properties, and houses built between 2000 and 2010 were actually more likely to be leaking than WCs in other properties. So in terms of the causes, and again drilling down further into the characteristics of the WC and the age of the property, and really looking for this relationship, the data here really shows that newer properties are more likely to have leaking WCs. I think 42% there is the figure that we show. But by association, they have a higher number of 6-litre flushes, and within those, flush valves. So there is this association between the change in the regulations and the potential for leakage. However, flush valves are more prevalent across all property ages. For every WC that was investigated, there were more flush valves than siphons, and that's because of retrofitting, because of upgrade, etc. throughout the years. But interestingly, overall 36% of those actually leak, and flush valves were associated with 81% of all the leaks we actually identified. Now, leakage in older properties was generally through flush valves, as I mentioned, and that's because of the renovation and the upgrade of bathroom suites. And I think the point I made about the 1970s through to 2000 earlier, I think there are a dwindling number of old siphon mechanisms that are perhaps still in those properties. So long-term owners that haven't upgraded their bathrooms yet, they still have the existing mechanisms or the siphons or whatever within their WC, and they're less likely to leak. So we see lower leakage rates in that property group. The rates of leakage in siphons are lower across the board at 16%. However, where siphons were found in newer properties, more of them actually leaked. Now again, that might be because there's been some retrofit or some twiddling by the owner or plumber, etc. So there's some interesting things starting to emerge from this. Now in terms of the causes, the actual physical causes, so we've got some associations, flush valves or siphons, etc., with different mechanisms. In terms of the causes, flush valve seal degradation was found to be the commonest cause. Now this is the seal that the flush valve actually sits upon to make the seal with the pan, so the water doesn't go through into the pan. And that's generally rubber or some sort of plastic material, which over time, of course, will degrade. However, nearly